Now we'll be talking about partial fraction. Now the method of combining two or more simple algebraic fractions to obtain a simple algebraic fraction is actually quite similar. Let's say for instance we have 3 over x plus 1 plus 4 over x plus 5. Now this can be combined together simply by, let's say, taking LCM. Okay, so we have x plus 1 and x plus 5, and we have 3 to x plus 5 plus 4 to x plus 1. So this will give us 3x plus 15 plus 4x plus 4, everything divided by x plus 1 and to x plus 5. Now this all together will give us 7x plus 19 divided by x plus 1 and x plus 5. Now this is made simple. It is quite simple, moving from two or more simple algebraic function to obtain a single algebraic fraction. Is actually simple. But suppose we start with this compound one and we want to go into the splitted form. Okay, so the process of transforming a compound algebraic fraction into sum of partial fraction is called resolution into partial fractions. Okay, so by convention, our partial fractions must be proper in the sense that the degree of the numerator must be less than the degree of the denominator. Okay, also they must be in their simplest form in the sense that they must not split into another. So now the partial fractions for any compound fraction will be determined strictly by the nature of the factors at the denominator. So that is why we have various types of partial fractions process. Okay, we have number one, we have those with non-repeated linear factors, non-repeated linear factors, and we have two non-linear, not repeated linear factors, non-linear, non-repeated factors. Okay, and we have number three, linear repeated. Okay, linear repeated factors, and then we have improper fractions. So partial fractions are characterized generally by the nature of the factors at the denominator of the compound fraction we are required to resolve. Okay, so these are the four categories of linear factors, of partial fractions. Okay, so we will be considering each and every one of them individually. So we will start with non-repeated linear factors. Non-repeated linear factors. Now we have two components. Okay, we have two factors. It's like the denominator are linear factors. When we talk about linear factors, it can be x plus 1. Okay, or let's see, these factors can be x plus 1, and it can be 3x minus 2. It can be x minus 4. And let's say even x plus 4. Okay, these are linear factors, like linear equation, 3x minus 1, and let's say 2x plus 3. So these are the kind of factors that are at the denominator. Okay, these are the kind of factors that are at the denominator. So in order to solve this generally, let's say we have two factors. Okay, let's assume we have question 2x plus 3 divided by x plus 1 and x plus 4. Now we can see that we have two factors, x plus 4, and also we have another factor, x minus 1, which both of them are linear. Okay, they are linear. So in order to solve this, we have to split them into linear factors as x plus 1 and also x plus 4. Now, what will be at each numerator? That's the question. What will be at each numerator? So at each numerator, we have something called variables. Okay, some use a, some use b, some use a1, some use ab. Okay, since the partial fraction is determined by the nature of the factors at the denominator of the compound fraction, therefore we can rewrite 2x plus 3 divided by x plus 1 and multiplied by x plus 4 into a over x plus 1, b over x plus 4. Now let's stop here and go back to what we started with. Realize that we had something like this: 3 into x plus 1, okay, and 3 divided by x plus 1 and 4 divided by x plus 5, and then we resolved, join these two fractions together to arrive at 7x plus 19 divided by the product of x plus 1 and x plus 5. So to go backwards, we see that we splitted them into two. That's x plus 1 at the denominator, x plus 5 at the denominator, and we'll call this one a, and we can also call this one b. So to solve this now is just like we will look for the LCM. So that means this is no longer, this is equivalent, okay, equivalent to this. Okay, it's equivalent to this. So all we just have to do now to solve this is to find a, okay, find the coefficient a and the coefficient b. Now, how do we go about this? So we can find the LCM of the right hand side. So we have 2x plus 3 divided by x plus 1 and x plus 4, and which is equivalent to a. Okay, let's find the LCM first. X plus 1, right? X plus 4. So this will be a divided by x plus 1, x plus 4 plus b into x plus 1. Now we'll see that this denominator, these two denominator, this and this, they are equivalent. So eventually we can multiply both sides by x plus 1 and x plus 4. So when we multiply both sides by x plus 1 and x plus 4, we also multiply this one by x plus 1 into x plus 4. So we realize that this will cancel out this, and this eventually cancel out this. So eventually we are left with 2x plus 3 is equivalent to a into x plus 4 plus b into x plus 1. Now when we arrive at something like this, there are two ways to solve the problem. We have the cover up method, and also we have the comparing coefficients method. Okay, and which one is easier, people might ask. Personally, I feel the comparing coefficients are actually like a little bit more easier, because you just have to simplify and compare and solve the simultaneous equations. And in partial fractions, you might have up to 17 simultaneous equations to be solved together. So but we'll try as much as possible to build on it, starting with a minimum of two partial fractions, two simultaneous equations. Okay, so we will try. Let's do the cover up method for the first example, and for the second example we will use the comparing coefficients method. Okay, so for this now, let's try using the cover up method. Now in cover up method, we have to eliminate a constant. Whenever we are looking for a, we eliminate b. Whenever we are looking for b, we eliminate a. So the question is if we substitute the value of x, okay, or let's just say what will be the value of x that will make a that will make this whole thing turn to 0, or what will be the value of x that will make this whole thing turn to 0. So let's when we put if we put x to be equals to -4, right? So when we put x into -4, this whole thing will turn to 0, because a into -4 plus 4 will be equals to 0, because -4 plus 4 is 0. And when we put x to be equals to -1, okay, this whole thing here will also turn to 0, because b into -1 plus 1, because -1 plus 1 is 0, okay, so everything there will turn to 0. So we can be able to simplify this function. Now we just have to start with 1. So let's start with the one of a, okay. Let's start with the one for a. So we put x into -4. So wherever I see x, we put -4. So that's 2 into -4 plus 3 is equal to a into -4 plus 4 plus b into -4 plus 1. Okay, so this will be equivalent to -8 plus 3, okay, is equal to -4 plus 4 will give us 0, right? -4 plus 4 will give us 0, and everything here return to 0. So 0 plus b into -4 plus 1, that's -3. All right, so this will give us -11, sorry, -5 plus 3 will give us -8 plus 3 give us -5, and this will give us -3b. So that means we're saying that our b, okay, so that's 5 is equals to 3b, and our b is equals to divide both side by 3, 5 over 3. Now we have solved for b. Now let us solve for a. Now that means we want to put x to be equals to -1. So when we put x into is equals to -4, we are solving for b. And when we put x into -1, we are solving for a, just for clear understanding. So when we put x into -1, wherever we see x in this equation, okay, like we did before, that will be 2 into -1 plus 3 is equal to a into -1 plus 4 plus b into -1 plus 1. Now -1 plus 1 is 0, so everything here turns to 0, right? So this will give us -2 plus 3, and it will be equals to a into 3, because -1 plus 4 is 3 plus 0. So -2 plus 3 is 1, and this is 3a. So our a will be what? 1 over 3. Now we have solved for a and b using cover up method. Now the best way to now do is now to recall this function. Okay, we recall what we have here. Okay, so recalling what we have there, we have 2x, okay, 2x plus 3 divided by x plus 1, okay, over x plus 4, okay, and it will be equal to a over x plus 1 b over x plus 4. Now all we just have to do is to substitute the value of a and to substitute the value of b, and a is equals to 1 over 3 and b is equal to 5 over 3. Okay, so having a to be 1 over 3 and b to be 5 over 3, so we substitute. So we have that it is 1 over 3 divided by x plus 1 plus 5 over 3 divided by x plus 4. So I'm solving this well. So we have 1 over 3 into x plus 1 plus 5 over 3 into 1 over x plus 4. Now we can leave our answer like this, or we factorize using 1 over 3. So this will be 1 over 3 into 1 over x plus 1 plus 5 over x plus 4. Alright, so this is using cover up method. Now the question might come and say, how about you use comparing coefficients method? Okay, So let's solve the same question using comparing coefficients method. Comparing coefficients. Now, there might be times that we might just have to select one, and there will be times that we have to select use the two methods as much as the question may be complicated into. So let's recall the question, and the question says 2x plus 3 divided by x plus 1 and x plus 4. Now, if we are splitting it into partial fractions, we have to, since the roots are non-repeated linear factors, so we have x plus 1, right, and we have x plus 4. So in that case, we recall that we'll be using a and also we'll be using b. Okay, a and b. Now, the first thing to do is to evaluate the LCM, right? So 2x plus 3 over x plus 1 and x plus 4 will be equals to x plus 1 and x plus 4, and this will be a into x plus 4 plus b into x plus 1. Right? So the denominator cancels out, so we have 2x plus 3 is equals to a into x plus 4 plus b into x plus 1. Now, we are not using cover up method, okay, so we are not trying to eliminate anything at the moment. So we just open the brackets and we have ax plus 4a plus bx plus b. Now, in this case, we bring the x together, okay, and the constants together also. That's 2x plus 3 is equals to ax, okay, plus bx plus 4a plus b, right? So let's factorize both sides here. This ax plus bx is x, so we have 2x plus 3 is equals to a plus b into x, okay, plus 4a plus b. All right, so now this is compared this as a coefficient of x, okay, so that means 2 is equals to a plus b and 3 is equals to 4a plus b. Now with this we have two simultaneous equations, right? So let's compare coefficients. So we have comparing coefficients. All right, so when we compare coefficients, we have 2 is equals to a plus b and 3 is equals to 4a plus b. So we have this to be equation 1 and also have this to be equation 2. So with this we will be able to solve no, we have two equations and we have two unknowns, okay, and for simultaneous equations to be complete, the number of unknowns must be equivalent to the number of equations, okay. So let's say from equation 1, I love to use substitution method. So from equation 1 we can make b Pareto formula, or a, anyone, but let's go with b. So from equation 1 we know that 2 is equals to a plus b, so therefore b will be equals to 2 minus a. So this will be our equation 3. Now we substitute equation 3 into equation 2. So let's recall our equation 2, that's 3 is equals to 4a plus b, right? And wherever we see b, we now substitute it with 2 minus a. So 3 is equals to 4a plus 2 minus a. This is important of brackets cannot be really overemphasized. So let's ensure that. So that means we have 3 is equals to 4a plus 2 minus a. Right? So 3 is equals to 4a minus a will give us 3a plus 2. Right? So let's make evaluate a. So that's 3 minus 2 is equals to 3a. If 2 that's if 2 goes to the other side. So 1 is equals to 3a. So I'm saying that a is equals to 1 over 3. Okay. Now, if we want to evaluate b, we recalled from equation 3 that b is equals to 2 minus 1 over 3. Okay, from equation 3. Okay, so I'll just substitute my a, that's 2 minus 1 over 3. So if we do this right, whether we calculate or something, we have our b to give us 5 over 3. Now A is 1 over 3, B is 5 over 3. Now these are the same answers we got using cover up method. Okay, A is equals to 1 over 3 and B is equals to 5 over 3. So as usual, we have to remember, go back to the genesis, okay, the of the work problem. So we will call it that 2x plus 3 over x plus 1 into x plus 4 is equals to A over x plus 1 plus B over x plus 4, and our A is 1 over 3 divided by x plus 1 plus our B 5 over 3 divided by x plus 4. So let's drop it down to make it more sense like we did before. So 1 over 3 into 1 over x plus 1 plus 5 over 3 into 1 over x plus 4. Now let's factorize this in 1 over 3 like we have before. So that's 1 over 3 into 1 over x plus 1 plus 5 over x plus 4. Now you can see that whatever method we use, it will arrive at the same thing. Now let's compare the lengths. Okay, we started with comparing coefficients. Okay, comparing coefficients is quite long. Okay, and why the cover up method, it's very straightforward. Okay, we're just trying to evaluate, eliminate a variable. So let's pick another question. Okay, let's pick another question. That's to be 2. We'll just stick to one method. Okay, so we use maybe comparing coefficients for this method, and for the next question again we will use cover up method again to solve it. Okay, so let's use this. Number 2, 7x minus 1 divided by 3x minus 1 and 2x plus 3. Now this itself is these two denominators. Okay, they are the first thing to check when we are solving partial fractions at the denominators. We have to ask our questions ourselves, but the first thing is, are the denominator factors, are they linear, are they repeating, are they non-linear, are they non-repeating, or are they improper fractions? So with these questions we will know this how to use. So now with this we see that the denominators are linear and also they are not repeating. Okay, so as usual we'll just split them. So we have this plus this because they are two roots, and if we have 3, they can be extended. All right, so we have 3x minus 1 as the first factor denominator, and 2x plus 3 as the second. So since they are linear equations, right, so we have A and we have B. Some people might choose to use x, and some people might choose to use y. Okay, some might choose to use A1 and some might choose to use A2, but I prefer to use A and B. Okay, so as usual we find the LCM. Okay, so 7x minus 1 divided by 3x minus 1 into 2x plus 3 is equal to 3x minus 1 and into 2x plus 3. So let's solve this LCM. So this will give us A into 2x plus 3 plus B into 3x minus 1. Now we can see the denominator are equal, so we can eradicate it or cancel it out. So we will have 7x minus 1 is equals to A into 2x plus 3 plus B into 3x minus 1. Okay, now we are using comparing coefficients here, right? Let's compare our coefficients here. So we have to open this up completely. Okay, so we have 7x minus 1 is equal to if you open this up completely, we have a multiplied by 2x, that will give us 2ax, okay, plus 3a plus b multiplied by 3x, that's 3bx, and b multiplied by minus 1 will give us minus b. Okay, so let's bring x variables together and coefficient variables together. 7x minus 1 is equals to 2a x, okay, 2ax plus 3bx plus 3a minus b. Let's factorize with x. Minus 1 is equals to 2a plus 3bx, okay, plus 3a minus b. All right, so now we can compare coefficients such that this is equal to this, and this is equal to this. Okay, so we are comparing coefficients. All right, so with respect to that, we can say that 2a plus 3b is equal to 7, and 3a minus b is equal to minus 1. All right, please remember that we have a plus sign here, and this is a minus sign here. So we can rewrite this to be 7x, okay, plus minus 1. So I believe it makes more sense now. So this minus 1 is this minus 1 here, and this plus, okay, is the plus here. So everything here is the same thing as what is here. All right, so having that been established, then now we have two simultaneous equations to be solved. Okay, two simultaneous equations to be solved. So I prefer to use substitution method, but whatever method you choose to use, just ensure that you get the right answer. So since I want to make find the most easy way to go about it, so I can make my b Pareto formula from equation 2. From equation 2, okay, I'll make b Pareto formula. So I know that 3a minus b is equals to minus 1. So if I want to make b Pareto formula, I take b from the left hand side to the right hand side, okay, so that will give me b, and I take minus 1 from the right hand side to the left hand side, that will give me plus 1. Okay, so I substitute b, so this is my equation 3. So I substitute equation 3, so into equation 1, right? So 2a plus 3b is equals to 7, and wherever I see b, I put 3a plus 1, so that's 2a plus 3 into 3a plus 1 is equal to 7. So 2a plus 3a times 3 will give me 9a, plus 3 times 1, 3, that's 7. So 2a plus 9a will give me 11a, and plus 3 is equals to 7. Okay. So with respect to that, 11a is equals to 7 minus 3. 11a is equals to 4, and a is equals to 4 over 11. Okay, now to solve for my b, I recall from equation 3. So my 3a, I know that my b, sorry, is equals to 3a plus 1, right? So my b, I've evaluated a before to be 4 over 11, and plus 1. So b will be equals to 3 times 11, that will give me 12. 12 over 11 plus 1. So you can use calculator to evaluate this, and our answer will be 23 over 11. So we have our final answer to give us a is equals to 4 over 11, and b to be equals to 23 over 11. Now the next thing to do is to go back to the genesis of the work problem. So we go back here and substitute our values of a and b. So recall that the question which says 7x minus 1 divided by 3x minus 1 into 2x plus 3 is equal to a over 3x minus 1 plus b into 2x plus 3. Now all we just have to do is to substitute our values for a and to substitute our values for b. Now our a is 4 over 11 into 3x minus 1, and our b is 23 over 11 into 2x plus 3. Now this will give us 4 over 11, okay, into 1 over 3x minus 1 plus 23 over 11 into 1 over 2x plus 3. Okay, and with respect to that, we can now factorize using 1 over 11. So we'll bring 1 over 11 outside, and we'll be left with 4 over 3x minus 1 plus 23 over 2x. Okay, 2x plus 3. Now this is what we understand by having non-linear, okay, sorry, we have non-repeated linear factors. Okay, non-repeated linear factors. So let's pick one more example. Okay, one more example. Let's call it example 3. Okay, example 3. So we are given 2x squared, and good, 2x squared minus 3x minus 10. Okay, 2x squared minus 3x minus 10 divided by x plus 2 and x squared minus 9. Now this is very important. You will notice that we have a squared here. Okay, now obviously when we have a square in an equation, it shows that it is not linear, right? So when we have a square in an equation, it shows that it is not linear. So question, how do we make it linear? Okay, of course we can solve this in non-linear fractions that are not repeated. Okay, this might even be our first question in the next example. Okay, so how do we go about this? Let's go back to our algebraic. Okay, when we have a squared minus b squared. Okay, this is like difference of two squares, will equals to a plus b into a minus b. Okay, now x squared minus 9 can also be written as x squared minus 3 squared, because 3 squared is equals to 9. So now if I write x squared, okay, minus 3 squared, so I'm saying that my a is equals to x, okay, and my b is equal to 3. Okay, and definitely if my a is x, so that will be x plus 3, and my a, which is also x, will be x, and my b, which is 3, x minus 3. So now since I have this, okay, which is equal to x squared minus 9, right? So definitely I can rewrite my entire question, this entire question, I can rewrite it and say that it is 2x squared minus 3x minus 10 divided by x plus 2 into my x squared minus 9 can now be rewritten as this, right? So into x plus 3 and x minus 3. Now if you look at the denominator, right, because the method we are using for partial fraction is dependent on the nature of the denominator. So now if we look at the denominator, we realize that all are linear factors and they are not repeated. Okay, all right, so now how do we go about this? As usual, since we have three factors, we have 3, 1, 2, and 3. The first one will be x plus 2, the second will be x plus 3, and the third will be x minus 3. So we can have A, we can have B, and we can have C. Right? So the best way to go about this now, the next step is to obviously find the LCM. Right? So we have 2x squared minus 3x minus 10 divided by x plus 2 and x plus 3 and x minus 3. Okay, for clarity, what is written here, okay, what is written here is what I would call difference of two squares. Okay, difference of two squares. So is algebraic in nature. So let's proceed. So let's find the LCM into of x plus 2, right, of x plus 3 of x minus 3. Now, so proceed further like this. So let's find the numerator. So a, like we usually do in secondary school. So a will be x plus 3 and x minus 3 plus b into x plus 2 into x minus 3, okay, and plus c into x plus 2 into x plus 3. Now we see that the denominators are the same for both sides, so they can be cancelled out, or we just multiply both sides by the denominator, so that eventually it will cancel out, right? So we have 2x squared minus 3x minus 10 is equals to a into x plus 3, a into x minus 3 plus b into x plus 2 and into x minus 3 plus c into x plus 2 into x plus 3. Now the question now goes is, what is the best method to use in this scenario? What is the best method to use in this scenario? So like I said, so most times I prefer to use comparing coefficients, right? So if you compare coefficients, we just have to open individually. Okay, we open these brackets. Okay, that means we have to open this before we now open it with a. Then we open this before opening with b. We open this before opening with c. But obviously it's quite stressful. Okay, so why not just let us use cover up method? Okay, so what we will put here, what we will substitute for x here, that will turn this whole equation to 0. Okay, so we want to try and eliminate a, we want to try and eliminate b, and we also want to try and eliminate c. All right, so let's look at the factors. A will come to 0. This whole thing will turn to 0 when x is equal to minus 3. That means if we put x to be minus 3 here, right? So minus 3 plus 3 we turn it to 0, right? And also if we put x to be equals to 3, okay, 3 minus 3 is 0, right? Since they're multiplying it together, everything will be 0. Okay, so what about this? For this, our x can be equals to minus 2, right? Because if we put minus 2 here, it will turn it to 0, and also our x can be 3, because if we put 3 here, it will turn it to 0. Okay, and for this we can say that our x is can be minus 2. Okay, because if we put minus 2 here, the whole thing there will turn to 0, and if we put 3, oh sorry, minus 3 here, minus 3 plus 3 we turn it to 0. So definitely we have 3. Okay, we have x to be minus 2, we have x to be minus 3, and we also have x to be 3. Okay, 3 common, and x to be 3. Okay, so if we use this 3 and start with it one at a time, then we'll be able to evaluate, right, which is which. So let's rewrite it. 2x squared minus 3x minus 10 is equals to a into x plus 3 into x minus 3 plus b into x plus 3 and x plus 2 into x minus 3 plus c into x plus 2 and x plus 3. Now let's say when we put x to be minus 2, let's put x to be minus 2. Okay, so wherever we see x, we evaluate wherever see x, we put minus 2, right? So in that case, putting x to be minus 2, so we have 2 into minus 2 squared minus 3 into minus 2 minus 10, okay, is equals to a into minus 2 plus 3, and this will be minus 2 minus 3 plus b into minus 2 plus 2 and minus 2 minus 3 plus c into minus 2 plus 2 into minus 2 plus 3. Now we can see we have this and we have this. Minus 2 plus 2 is 0. So everything here will return to 0, and also everything here will return to 0. So we are left with just these two equations. Okay, so let's solve for that. So 2 minus 2 squared is 4, minus 3 into minus 2 minus 10, okay, is equals to a. Minus 2 plus 3 is 1, and minus 2 minus 3 is minus 5. Okay, so this will give us 8. Minus 3 minus 2 will be 6, and minus 10, which will be equals to minus 5. So 8 plus 6 minus 10 is 4. and it's A minus 5A. So with this we have A to be equal to minus 4 over 5. Alright, so what next? Let's put X, okay, to be equal to 3. I believe, no, the next one is minus 3. We've done this. Now let's do minus 3. Okay, so wherever we see X, we put minus 3. Okay, so that means we are still using this equation. 2 into minus 3 whole square, minus 3 into minus 3 minus 10 is equals to A into minus 3 plus 3 and minus 3 minus 3 plus B into minus 3 plus 2 into minus 3 minus 3 plus C into minus 3 plus 2 and minus 3 plus 3. Now let's see something. Minus 3 plus 3 will turn it to 0, and this also minus 3 plus 3 will turn it to 0. So we are left, this cancel out to 0, this cancel out to 0. So we are left with this and this. Okay, so let's solve further. So we have 2 minus 3 squared is 9, minus 3 into minus 3 minus 10, and we will solve this. Okay, so that's B into minus 3 plus 2, that's a minus 1, and minus 3 minus 3, that's minus 9. So this will give us minus 1 multiplied by minus 9 will give us 9B. So let's come to the other end. So 2 multiplied by 9 is 18, minus 3 multiplied by minus 3 is 9 minus 10. So this would give us 30 total. I'm not mistaken. Okay, there's a mistake somewhere, sorry. Minus 3 minus 3, sorry, minus 3 minus 3 is minus 6. Okay, let's say apologies, is minus 6, and this will give us 6B. Okay, so here we will have 9 minus 10 as minus 1 minus 18 give us 17. Okay, which will give us 6B. So definitely our B is equals to 17 over 6. Okay, now finally we have to put X to be equals to what? 3. So X is equals to 3, then X equals to minus 2 and minus 3. So we are still using this equation. So we'll follow the same format. I think I have it in my head, so I follow what we've done before. So that will be 2 into 3 squared minus 3 into 3 minus 10 is equals to A into 3 plus 3 into 3 minus 3 plus B into 3 plus 2 into 3 minus 3 plus C into 3 plus 2 and into 3 plus 3. Okay, so with respect to that now, with respect to that now, we can now see that 3 minus 3 here and 3 minus 3 here is 0. So this will be 0 and this will return to 0. So we are left with this and also we are left with this. Now, so solving this, we have 2 into 9 minus 3 into 3 minus 10 will be equal to solving this be C, and 3 plus 2 is 5. Okay, let's not make the same mistake we made earlier. So 3 plus 3 is 6. Alright, so we have 18 minus 9 minus 10 is equal to 5 times 6 is 30. C. Okay, and 18 minus 9 was 9 minus 10, and that will be minus 1. Okay, equals to 30C. So I'm saying that my C is equal to minus 1 divided by 30. Now, since we have our values for A, okay, we have our values for B, and now we have our values for C. Our A is minus 4 over 5. Our B is 17 over 6. And our C is minus 1 over 30. So as usual, we go back to the beginning. So we copy. Remember, this is the beginning. All right. So we have 2 squared. Okay. So 2x squared. Okay. Is we are always considering the denominator to know what we are using. What's the numerator? 2x squared minus 3x minus 10 into x plus 2, and please remember to follow the same format which you have at the beginning. Okay, we have x plus 2, we have x plus 3, and we have x minus 3. Ensure that it's the same format, okay, so that we don't get it all mixed up. So that's x plus 2 and x plus 3 and x minus 3. So this will be a divided by x plus 2 plus b divided by x plus 3 and then plus c divided by x minus 3. So when we substitute, we have minus 4 over 5 divided by x plus 2 plus 17 over 6 divided by x plus 3 and plus c divided by x minus 3. Sorry, our c has been substituted to be minus 1 over 30. So let's try to make it all linear. Okay, that's to be interesting. So let's bring the 5 to the denominator. That's minus 5 divided by 5 over x minus 4 divided by 5 over x plus 2. Those let's bring the 6 to the denominator. That's 6 into x plus 3. And let's bring the 30 to the denominator. That's 1 minus 1. This minus will have affected this plus. Okay, it was minus times plus will all give us minus. So we have it. So that's 1 over 30 into x minus 3. Now this will be the answer to the question. So which one would you have preferred? Would you have gone for the comparing coefficients method? Okay, it will also arrive at the same answer, but most of the times it might look a bit choked up even cover up method, but when we actually enter comparing coefficients, we'll see that comparing coefficients is actually like the joy, but because you have to just open all the brackets and then compare it to what you have. All right, so let's take a quick recap on the process of solving non-repeated linear factors. Okay, now if we look at them, they are linear factors in the sense that they don't have powers of greater than 1. Okay, so the is just 3x, 2x, and sometimes can just be x. So we split them as usual. The first factor takes the second one, and the second factor takes the second, and if there are more, it can even be 4. So we do a and b. It can be a1, it can be a2, and it can be ax and y, as the case may be. Okay, and then we find the LCM. After we find the LCM, we either compare the coefficients or we use cover up method. So and at the end we have we'll have 2 answers for A and B, and it can also be C like our previous example. So with that, we can now substitute values for A, and when we substitute values for A, to be 4 over 11 as we have here, and B over 11 as we have here. Then we simplify further, and we did the same thing for 3, that's ABC, and then when we simplify further, we have this. So in our next video, we'll be talking about factors that are non-linear. Okay, yes, factors that are non-linear and they are not repeated. Okay, and with that, we'll have another technique to go about it. So join me and don't be scared about it. It is actually very, very fun. All right, see you soon.